All right, everyone. So welcome to this month's call for the Systems Spacing Group. Before we get started and introduce our speaker, I want to just touch on the SIG-HP SysPros workshop, which will be happening at SC this year. Will be a virtual workshop, so you don't have to attend in person if you don't want to or can't. But the deadline for submissions, I have extended it from Friday until Sunday at midnight from anywhere. So, if you haven't thought about it yet, please consider, submitting, lightning talk, a long form talk, or even a paper or artifact describing a certain piece of your infrastructure, architecture, what have you. For a lightning talk or talk, just send us, a couple paragraphs of an abstract, and that'll be good for us. But please do consider submitting. You don't have to attend, in person. Again, you can attend virtually. So please give it a thought. But now on to the main event. So our speaker, Eric Tomeo, is the operations team lead for the University of Florida Research Computing. He has been at the University of Florida for about 5 years now. And most recently, University of Florida has put in place a new computer called HiPerGator AI. This supercomputer is one of the most powerful university-owned supercomputers in the nation. What this also means is that maintaining the availability and reliability of the system is paramount. And so he will be talking about how him and his staff plan to maintain these valuable resources. Eric, take it away.
Thank you, John. Thank you for having me for this session. It's the first time I've actually done one of these things, so bear with me. But looking forward to kind of demonstrating what our environment looks like a little bit, and I'll get into some of the things we're having to manage with such a large GPU base. So let me get my slides started. All right, is everybody seeing my slides there?
Looks good.
So like I said, John's mentioned, I'm a systems administrator. I mean, my technical title is system administrator 4, but I am also the operations team lead. And like I said, I've been here about a little over 5 years. And yeah, this latest system, the HiPerGator AI is what we call it, but it was, actually, I guess I touched on the next slide. So let me tell you exactly what it is and where it came from. So the AI cluster, as we call it, is really comprised of a SuperPod. The term SuperPod really represents a cluster of DGX A100s. Really, it's 20 or more. So we kind of have multiple SuperPods, or what they've actually boiled down to scalable units. So each cluster of 20 nodes, and if you look at kind of the left side of this diagram, you can see there's 2 racks here, then there's one in the middle with the networking, and then there's 2 more on the other side. That 5-rack setup really is what's called a scalable unit. And we have 7 of those. So that gives us 140 total DGX nodes. And with 8 GPUs, or 8 A100 GPUs per node, it gives us a total of 1,120. On top of that, each node has 10 HDR200 InfiniBand connections, which again, that we end up with 1,400 IB connections there. And then each node also has a 2x100 gig Ethernet link to give us another couple hundred connections. So you can see in this image, a kind of a fisheye image, there's 2 scalable units with a central network aggregation. Unfortunately, this is the back, so all you see is power cables, but you can imagine what the front looks like. This system, when we put it in and did our top 500 runs earlier this year, we ended up number 22 on the June 21 top 500 list. So once we added this system, we now actually have more than 1,700 GPUs total in our environment. And really, to put that into perspective, we only have about 1,500 total nodes that are in the whole cluster. And that includes some of these GPU nodes. So we're really GPU heavy at this point. And again, the AI cluster was made possible through the Nvidia University of Florida partnership. There's been lots of publicity around that when it happened. It really started at the end of 2020. There was a donation from Nvidia plus some UF investment and a lot of staff effort to get this thing going. I can't even begin to tell you how much time and effort went into actually setting this thing up. So again, millions of dollars worth of equipment came in, but are researchers using it? What are they doing with it? That's kind of been the upper management's ask lately is, are people using it? How are they using it? And how do we represent that? That, obviously when they ask for those things, we need to try and provide. So one method really to look at is metrics, collecting metrics over time. It allows you to create fancy graphs, and that's usually what upper management likes, right? Let me see a graph of where we're at now, what's the utilization look like? And that's the most common thing, right? Is what, is it 80% utilized? Is it 50% utilized? I don't think anybody wants, a multi-million-dollar machine to be sitting there at 20% utilized. There's also been some interest in kind of the what is being used, or what are people running? What are the applications? You may have been a little bit familiar with kind of the Gatortron project that we've had that started early this year. Was a big kind of an integral part of the GTC, the Nvidia GTC early this year. So that's kind of been the main application so far, but we've since kind of released the cluster to users. So now we've got to get a little more specific about trying to track down that information. But I mean, how have we been doing so far on that? Not all that good. Before the AI cluster came in, we got a lot of complaints from researchers that there weren't GPUs available. We had like maybe a little over 500 available, but they were pretty heavily utilized. It was becoming hard for users to request a Slurm job and get landed on a GPU node. So unfortunately, we didn't really have any good metrics for that. We didn't have any information that was telling us, oh, hey, we are at 95% all the time. And that kind of goes back to, well, when the users are telling you there's a problem, that's even a bigger problem. So it's kind of our main focus now, really, as to how do we monitor these things and how can we track what's going on. This is a note for pretty much the rest of this talk. Our main operating system that we use for HiPerGator is Red Hat. DGX nodes, they can run a DGX OS, which is kind of like an Ubuntu-based system that is purpose-built for the DGX systems, but we're running Red Hat everywhere. And we do not do anything with containers or Kubernetes on HiPerGator today. So anything in here, if it's referencing repos or packages, it's going to be all Red Hat based. So the first package really from NVIDIA is the Data Center GPU Manager. It's available through the NVIDIA. There's some specific DGX repos where you can get this package. It's also available in the NVIDIA developer repos. And again, the package name is just Data Center GPU Manager, and that's what we're running now. And for the DGX ones, there's another one. It's the Fabric Manager. I think it's just kind of adds some features to the DCGM. Not doing anything yet with Fabric Manager, but it's it is a important piece of the DGX system, especially when you start to get to kind of multi-node, multi-GPU applications and jobs. In DCGM 2.0, which was the one we were running originally, there's some funky DCGM enablement package. It's more like a meta package that actually just starts and enables the service. Could be something useful in environments where there may be no automation or config management. But the current stable version that's out is 2.2.8, which is what most of my testing has been. There's not a ton of differences between the two, but we do want to try and stay current there. And there's a link to a thorough guide from NVIDIA that kind of walks you through how to set this thing up. But I'll kind of give an overview as to how some things that I've done, some things that I've run into, and then we'll get in a little deeper as to maybe what we're planning to try and implement here at UF. So there's a couple different ways to use the DCGM utility. One would be to use it as an interactive tool. So there's a command DCGMI, once you get the DCGM packages installed, where you can create a group. You can create a group based on the number on any GPU device. So again, we have 8 GPUs in here. There's 0 through 7. So you can create any kind of group with any various GPU IDs. So you see here, I simply just created a group. I gave it an ID of 4, and the group name is just test1, and it's got the entities there. I've not gotten into NV switch stuff. That's something we'll probably want to look into at some point, but the group 2 and 3 here, those are default groups. So even as soon as you install the system and you run this DCGMI group list, it's going to give you group ID 2 and 3 by default. So once you get your group created, you need to enable the stats for that group, which is just a simple command here at the top. I do apologize, just a lot of text pasted onto the screen here. So it starts watching on that group, and then you need to enable the job start. So a job is effectively a recording job for statistics. There are additional flags, even for setting interval. I think the default is 3 seconds, if I recall correctly. But so it will just start recording various information in the background once you kick off the job start. And also when you're done recording the statistics, you can stop the recording. You can run it live, so you can actually just look at it while it's running if you run the same command for --job test1 job. It'll give you the stats even if you haven't stopped it. But it's worth mentioning that once you stop it and you're done, you can remove the statistics with a J remove, and then you can remove the group. That's kind of how you clean up after this. But you can look here, there's not unfortunately what we found is not a ton of useful information in this kind of the job recording, the statistics recording. But one thing to mention, it does show you power usage. It gives you an average, at least, max and min are not available. It does give you, it would give you probably some errors if there were any kind of memory errors on the system. It gives you what the max memory that was used, and the number of processes that were run is 4. And you can kind of see that over here from an Nvidia SMI output. That's one way to kind of see what is happening on your system. So it looks like there's 7 processes, but I think these 3 are not really, it's part of how the Amber application that I was testing with distributes, but there's 4 main processes. So that's what this is picking up. And I ran the job recorder for 352 seconds. So I'll show you some more later on how to get this a little better. And actually you can see here, it says available per GPU in verbose mode, and that's what the next slide is. So if you kick off that job, the stats for group 4 and that job that we were discussing and add a verbose flag, you can now see it'll give you each GPU 0 through 4 or 0 through 3. But for here, I just grabbed a couple of them for demonstration. So for these ones, I ran them for 90 seconds, and you get a lot more information here now. So you can see your SM clock. Well, the clock speed's not going to change, but your utilization, you'll see your average is 70. It hit a max of 98 and a minimum of 31%. Same with memory. And it will also give you that process information utilization. So a little more useful here. And I'll show you in a few minutes how, where we can maybe apply this. If you are using, you can use DCGMI, the Dmon utility. It's pretty handy. It'll actually kind of show you what the data is, as opposed to just giving you an output at the end. So this has been handy for me for testing also. You can reference a group. So in this case, I have group 25 as another test, or group 4, like we had showed in the previous example. And then there's a couple flags. You can use the -E for a field ID. And there's a huge list from Dmon-list, or you can use a field a field group ID. I actually haven't quite figured out field groups, but it's easy enough using the field ID and then setting a delay of 5 seconds. So just give me an output every 5 seconds of -E. 203 is the field ID, which you can see by the kind of the short name, as they call it, is GPU utilization. So while, I mean, you can run this at any time as long as you have a group set up. So you just call the group and it'll pick, it knows that only GPU 0, 1, 2, 3 are in it. And here's the data for that, when it queried at that time. Then 5 seconds later, it'll spit out another output. So this may be useful in other kind of collectors to put together and send either via telegraph or some kind of Prometheus exporter, which I'll also get into here in a minute. You can do comma separated for ID. So here I just did the GPU utilization and the memory utilization, but you can obviously expand that list or work with the field groups, which I believe should give you a whole grouping. All right, so I said we're going to try to apply this, and one way is the DGM Job Stats. There's actually an Nvidia documentation on how to do this. So most of what we've done is quite similar to that, and I have that listed on a reference page at the end. I'll show you. But effectively, this will leverage Slurm's prologue and epilogue scripts. The prologue will effectively, and most of this will do what I've shown you, but it'll automate it, where it'll create the group, and we're going to use the Slurm job ID environment variable for that name. And we'll grab the CUDA visible devices from that environment variable and use that to pass to that group. So if you only use 2 GPUs, those 2 GPUs that are used by that job will be assigned to that group. And then it'll enable the DCM, the stats watches, and then it'll start the job. So once the job started, then the background process will be monitoring for that group, and the job runs. When the job finishes, the epilogue script then will take care of stopping the stats job. It'll dump all the outputs to a temporary file, at least that's what we're doing for now for testing. And then it will remove that DCGM group that the prologue created, so you don't end up with a huge list of DCGM groups. Right now, what we're looking to do with that is apply it to, more or less just land it on all the GPU nodes as kind of a system level thing, and not really letting users control it, although there are mechanisms to allow users to do similar functions. There's nothing really stopping them from being able to do it themselves. So here's the actual job stats scripts that we're using, or the prologue and epilogue scripts that we're using. So this will be available on the slides. But more or less, this is just the code for what I explained in the previous slide. So it's pretty handy. So once the job is complete, or actually while the job is running, if you want to interactively go to the node, you can look at the list and you'll see list. Group 25 shows up. The group name has, we preface it with group just so we can differentiate it for now. And then this 861 is the job ID from Slurm. So once the job is done, this group will go away, but we'll have a stats file here that we just store right now for our temp. We put in the host name, the job ID, and then you'll see here that in the output it says retrieve statistics for that job. So we can reference that with some kind of collector, or go in here and parse the information and go from there. So you'll see this is very similar to the information, and again, it's per GPU that I showed you earlier, but this is more of an automated fashion. So what next, I guess, we want to do with this, and there's a lot of options using Prometheus exporters and Grafana. In digging into DCGM, I've become inundated with Prometheus exporters. It kind of seems to be the way Nvidia is doing it. They have a full system that's called, well, there's a couple systems. There's one called DeepOps, and then they have a new one I think they're rebranding called Base Command, which effectively leverages a lot of these utilities and puts them together to get the same information really that I'm doing a little more manually. So a couple of the exporters I'm looking at, one is the NVSM exporter. That one is kind of a native DGX branded one. It comes with the NVSM package, which I believe is only available for the DGX node types. And it's mostly used for system errors and alerts. It'll track like an error count, it'll track memory errors, it'll track PSU errors, but it does provide other information like GPU utilization, but nothing super specific as far as like, useful for time series, unless, again, you're wanting to see more errors and alerting type metrics. This one does come with a native systemd unit file. Like I said, we're all Red Hat. So this one's handy. It's just once you install the package, you can start the service and it starts running on port 9123. With the data center GPU manager software, it comes with a Prometheus. Actually, it comes with a handful of Python bindings. The one that has been of most interest right now is the Prometheus one, and it works on pretty much any GPU platform against Python code. As long as you have the DGM service running, it should work. I have it running on non-DGX nodes, and it seems to work just fine. More current versions have some Python 3 bindings, but this package does require the Prometheus client to be installed. And there's a couple of different ways to do that. You can do it with either a pip install, or I think there's an RPM available on maybe Apple repos. This one, though, runs on demand, or of course you can background the task if you want. For now, I just kind of have several sessions open where I'm just running these kind of in the foreground so I can see what's going on. And this one by default's run out on port 8000. Not to be too confusing, but there's another DCGM exporter, which is available on GitHub. This one was provided by Nvidia. It's all open source at this point. And this one's written in Go, which seems to be the common trend these days in the Prometheus world, it looks like. A lot of the exporters that I've come across are all Go based. This one I've been using the most because it more closely matches the DeepOps dashboard. So from DeepOps, there's some sample Grafana dashboards that you can import. And it looks like this exporter was maybe designed to be used with it. So I'll show you some of that in a minute too. Unfortunately, it also kind of runs on demand in the foreground, but you can background it as well. And the last one is the standard Prometheus exporter. It's just the standard node exporter. If you get the packages, the RPM packages, it will come with the systemd unit file as well. But it's more useful for just general node metrics. And a lot of this stuff is going to be repeated in some of these other ones, but there's definitely work to do there, and there may be some useful information from that one as well. So it's been quite a battle trying to pick through all of these. As I mentioned, you can import Grafana dashboards. I'm sure many of you are familiar with Grafana and how it works. So some of these exporters, they have like a sample dashboard you can import, which is nice. They're typically in JSON format, and then you can just drop it right in. But I found in doing that, it's usually of interest to try and open the code first in some kind of normal editor, and then import it, because there may be some things that are not kind of drop-in compatible with your setup, or you may want to change some values and from text instead of trying to do it from inside Grafana. So if we look at this is from the DeepOps dashboard, so no, I didn't custom create all of this. I will not take credit for it, but it's available. It did require some fine tuning though. Like I mentioned those various exporters before, and I'll go through a couple of them, but some of these graphs, panels, I guess, leverage a different metric. So some may reference NVSM data, some may reference DCGM data, some may reference node exporter. So I think there's value in maybe having multiple, and it's just going to be picking through which ones and then picking which metrics from which provider make the most sense. So this is one of the test jobs that I ran. You can see the power usage has kicked up once the job had started, and you'll see the temperatures of the GPUs increase at the same time. GPU utilization, I did hover over this one for the image so that you can see GPU 0, 1, 2, and 3, like we're showing in that job, are the ones that are active. The other 4 GPUs are idle. So this, an interesting graph. But this is on a per node basis. So still working on how to kind of correlate or aggregate all 1,120 GPUs into a single dashboard. Maybe some complications there, but there's probably ways to do it based on averaging. So it's a really handy dashboard. Like I said, it took me some time to pick through each of these and match up the kind of the field identifiers, so to speak. But I'll pick through this a little bit more. So for example, just grabbing GPU temperatures. This one I collected an average. There's a handful of nodes that are sending metrics now that are the NVSM. So Prometheus, if you guys have not been are not familiar with it too much, it's really simple to set up. I'm not going to go into how to set up Prometheus per se, but when you get the data in, setting up these dashboards is I think maybe even a little easier than Telegraph and Influx. Really, it does a very good job of auto completing. So you can literally start typing in NVSM and it will tell you all of the fields in the database that start with that. So picking through, you'll see that this one comes from the NVSM exporter. And then there's some different identifiers within the data that you can choose to select which metric you want. And here I'm just averaging them across all the nodes that are sending data. And then with another NVSM output, it's just the GPU count. I mean, it may be interesting because the NVSM output, if it only detects 7, it's only going to show 7. So you may see that here. And this one's on a per node graph. By changing the legend, you can select instance, which is kind of just a variable for the actual instance name. So it could be useful, but again, just kind of demonstrating some different ways to set these up. Another thing that I did kind of for fun, the graph on the right, the GPU utilization, you'll see I have 2 different exporters. I use the DGM exporter and the Prometheus one, as I mentioned earlier. Same job, same data, but obviously it doesn't look quite the same. They're a little bit offset, but it's ultimately going to depend on at what exact time was the metric collected, and at that exact time, what was the value. So you can see they're close, but they're off a little. So I mean, if you stick with one, I think it'll be less of an issue, but just kind of wanted to point that out. And again, so here's this is a panel taken from that large dashboard that I showed earlier. This one comes from the DGM exporter, the Golang written one. So it pulls the node from the host name, where host name matches the server up here. So if you change the server to a different node, it'll change the graph to match that server. So this is just pulling again the GPU utilization. You can break, and it's broken down by GPU again by using the legend. If you hover over those, you'd see each GPU individually. And as mentioned, there's this is the node exporter. This is the standard Prometheus one, but it natively can do the load outputs. So maybe for core metrics or things that may not only be needed for like GPU type metrics, you could use this kind of cluster wide and get an idea of other data. There's quite a bit of data in the standard node exporter, but we do need to watch out obviously for redundancy. And again, this graph obviously shows where the GPU job started. One other, so I guess that pretty much wraps up for the Prometheus and Grafana stuff. But one thing we're looking at doing also to try and help manage our GPUs is inside Slurm or Slurm shop. The gres.conf has gotten a little bit nasty now that we have all these GPU nodes. I'll show you a sample here in a second of what ours looks like. But starting with 1905 version of Slurm, you can configure GRES to use NVML to detect the GPUs and their specs. Just be sure to build, if you do set this up, to build Slurm with NVML. It's like a libNVML support, or it won't work. We just use CUDA NVML devel to do it. There may be some other dependencies as well, but just be sure to build it with the libNVML support. There's plenty of documentation out there on how to do it. I believe it works with any NVIDIA GPU, but as I've already found, there's maybe some features that are not supported. If you're not leveraging those features, though, it shouldn't matter. Slurm still starts and accepts jobs, but it does throw errors. They did make a nice change in 2011 or 20.11 with GRES. You can now supply auto detect NVML for any given node. Before, you could either, it was kind of an all or none, so we didn't really pay close attention to it at the time because that was probably more than we were ready for. But now you can specify a node name, and I'll show you how we did that here in a minute. So for the GRES, our current config, this is just a snippet, it's not even all of it. You'll see we have our various nodes, and they're each broken out kind of by NUMA core based on maybe LS Topo, or there's another NVIDIA SMI way to get its NUMA topology. So we kind of matched it up with that. So that's how our original file looked. But you can see on the node that I'm testing on, I went in and said, just let NVML auto detect its settings. Once you do that, it then, when you restart Slurm, I turned up debug so I could actually see what it was doing. You'll see that it detects eight devices, and then it normalizes the GRES. It goes through a couple iterations of finding out what the GPUs look like. And here you can see it actually does match what we've shown up here earlier for our other nodes. So we'll build this out, and it keeps track of the NV links as well, which is one thing that we don't have in our static config. And then, like I said, it breaks it out for each GPU, 0 through 7. We're still testing this. We haven't rolled it out into production yet, but it is something we're looking at doing. When trying to run this on a non-DGX node, like I said, we set it up similarly, but it produced some errors on getting supported memory frequencies. I don't know if these are, I think the node I was complaining about is C38 node. It has, I think, some RTX series GPU. So still working through that. But that's just, again, something to watch for. But it's a very handy feature in general to have it kind of build that list for you and not have to maintain these interesting strings of mapping your NUMA cores to your GPUs. Some additional information, again, some things to watch for. I mentioned that Nvidia DGM enablement package. Looks like, though, they may have done away with that, as there's on the newest version of DCGM, there is it's changed now to Nvidia DCGM.service. And it will give you deprecated warnings and errors about the old one if you happen to have them both on. But it doesn't look like, to me, it's still enabled and started by default. But again, config management automation will help that. Other things I ran into, DCGM, the new DCGM has Python 3 bindings, but I haven't gotten any of them to work. Every time I try to run them, it looks like there's some code issues that need to be modified. But even the Python 2 bindings give me some interesting tracebacks. If I open up kind of a web browser to go to the metrics sites, it gives me this error that status must be a string. Haven't spent a lot of time into it. It does seem to be collecting the data as I expect. Some other things running into, if you stop or if you try to remove or disable the job watcher, it doesn't like it. You can stop the job, and then you can try to disable the job, but it just says it can't. But then it seems removing the group altogether has solved that problem. So just, again, something to look out for. Some future work that we're looking to do. The big thing, again, was kind of the push from upper management, right? It was, what are people doing? What's the applications? What is the what does the utilization look like? we kind of want to maybe see that on a per job basis. That way it's a little easier to say, when a job runs, it's using 80% of the GPU. If we leave it alone, if we just do general utilization, well, there's going to be plenty of times where it's at 0 and maybe not doing anything. So we want to try and keep, that information available so that we can say if a job is running, what are people doing? Are they actually utilizing the GPU to full potential, or are they only using 10% of it? So, but the challenge has really been trying to correlate that information to a job ID. I mean, there may be some ways, but we're still a little bit early in the process, but it definitely is information that's being asked about. Ideally, we may use a Prometheus exporter, but we're looking at Telegraph as an option as well. We're a little more familiar with Telegraph here. We do write a lot of custom plugins there. So maybe, and there is actually a Python binding for Telegraph. I haven't used it yet, but it's on the list of things to do. Telegraph does make it a little easier to add custom tags to our data. We do it a lot right now, so it may be a viable option for us. The Prometheus stuff, I don't know Go at all, but maybe someone else can get in there and figure out how to manipulate the data and add some custom tags. So again, as I mentioned, all the various exporters, what we want to do is probably pick the ones we want, and then we'll deploy those cluster wide. My guess is we're not going to need both the DCGM exporters, either the Go version or the Python version. Try to maybe standardize on one. And something I read in my kind of research on a lot of this was to really make sure that you're not collecting unneeded metrics. And it was a valid point that I didn't really think about until I read it, that if I'm running 4 exporters, there's probably 80% overlap. So something to keep in mind is definitely to clean that up and only grab metrics, one, that you're going to use, and two, only collect it from one utility. So I think that would be some effort, but it'll be worthwhile for sure. Then once we get the Slurm job information, either through Prolog, Epilogue, what have you, I think getting that application utilization will be a key piece to really providing good insight as to how these GPUs are being used. So this is just a giant list of references. These are some pages that I visited in this process. This really is a timely discussion, as it's one of the kind of our big tasks right now. We're being asked to provide metrics and data. So it's kind of been on my radar for the past couple months. And actually this has been a good exercise for me to get more familiar with a lot of these packages, and I'm learning a lot here. And these are some of the areas I visited that have had a lot of useful information. So let's see, that is pretty much all I have for everyone. So again, appreciate the time, and I think we have time for questions.
Yeah, thanks, Eric. So if anyone has any questions, feel free to unmute and ask away.
So maybe I'd start with the first question. And if you touched on this, then I'll ask for forgiveness for not having caught it. But kind of with that aspiration of getting per job level statistics, not related to GPU, but the XDMod Supreme world has tried to tackle part of that. Using the underlying layers of either TaxStats or PCP. Have you looked kind of that direction to see if you could build off of that to kind of bring the GPU stuff that you're capturing from these things into that to kind of then associate them at a job level?
That's true. Regarding XDMod, yeah, we actually we had it running some time ago. But I don't recall if it was, it wasn't real well maintained by us, but it was something that we did have in place. I haven't looked at it, to be honest, since then. But yeah, it may be something of interest to implement and see if the two could integrate. But what stats that you said?
So somebody else on here, Paul's on here from our site, so he actually knows a little bit more about this, but I believe that the XD mod needs things in the PCP data format, but you can get it through TAC stats, which is a package set made by TAC.
Okay.
But I think it ends up converting the data into a PCP format before it gets fed into XD mod, if I remember right. And this is an area I'm not super clear on.
Okay.
But some of the niceties there is it's already leveraging things for the system side, right? C groups, so it can go and see the utilizations and everything at the job level created by the C groups the Slurm is setting up.
Right.
There's not really a C group around the GPU. I mean, yes, you can control what devices are available. So it's very interesting to kind of see what you're gathering from these things and see that possibility of just snapping these things together. And then you already have a very nice UI, that's user focused, and that may not be the UI that you're after, but it is a UI that's useful in the right case where the user wants to see their, job utilization and various metrics in that regard.
Yep.
So Eric, what's the utilization been like on the DGX SuperPod? I mean, I know you mentioned that users were complaining about GPU availability before. Has that been a continuing complaint? Do they still want more?
Well, they always want more, right? That's just how it works. Most of the complaints about availability have gone away. Now it seems to be every once in a while still a scheduling or time to schedule post after submission, right? We do have a lot of GPUs, but there are still a lot in use. And I think it depends on really the job size that users are asking. If they still want 16 GPUs, well, there's probably 16 available, but Slurm tries to keep things close together, and it tries to keep things in kind of a scalable unit almost, because for the NVLink type stuff and then the switching fabric, it wants to keep things together. But we have a lot of users, so it's possible there's only one GPU per node available. Actually, I didn't show one of my dashboards I have now that tracks that, actually like a heat map that shows a majority of nodes are using 7 to 8 GPUs. So if they're using 7, it does make scheduling a little harder to find a place to put 12 GPUs. You need to get 12 different nodes in order to run that. So that's the current issue. But as far as utilization, I do run a monthly report right now on that. Actually, I don't have that in front of me. But we're 60 maybe in terms of allocation, not necessarily what is the utilization of the GPU, but we're probably 60 to 70% allocated at any given time. So there's still room. I just think one thing I'd considered is maybe jobs just take less time, right? I mean, these are pretty phenomenal GPUs where they thought maybe it was going to take 2 days to run. It could maybe run in an hour. So jobs are going to finish quicker, which means there will be maybe slightly less or slightly more idle time.
I had a quick question. It's not necessarily within the scope of the particular subject matter. It's more regarding Prometheus itself. I was curious. I've got a Prometheus setup deployed around our clusters at Purdue. I was curious what kind of scrape intervals and things like that you were running, and if you would run into any issues with having the default anywhere from 5 to 20 second recommended scrape intervals running that, or if you've bumped it up into the minutes.
Yeah, right now I have it just at 30 seconds for the scrape intervals. And I am still running all 4 exporters, but I don't have all nodes running all the exporters. So I'm sure I'll need to make adjustments, but for right now, 30 seconds seems to be fine. We do have a relatively new, actually with the whole AI cluster, we did get a couple pretty beefy nodes to handle the metrics. So
Yeah, I'm running on VMs with 100 gigabytes of space at most. So
okay, yeah,
I've had to kind of make some drastic adjustments there,
yeah.
but it still works fairly well for us. So
Okay, yeah, we have a physical box with about a terabyte of local storage. I am worried that maybe we'll even hit a terabyte.
yeah,
It's a pretty good local physical node. Like I said, 30 seconds for now, but once I start sending 140 nodes worth of a lot of data, that may change. I would.
Maybe some of my management chain is listening.
Yeah, speed IO on these things is important to get all that metric information in. Even we have an influx server too. We went with physical box for it, with local storage, RAID disk, high core count or high clock count on the CPU cores.
Another utility might be instead of Prometheus, look into Victoria metrics. It's a Prometheus compatible metrics gathering tool. It's a lot more efficient in storing the data on disk. So it sort of gives you more compression, and it has the ability to handle more data than Prometheus does. That's what we have at UGA, and we are very happy with it.
Okay, you said what was Victoria metrics?
Yes. We run it in cluster mode. So we have 2 nodes doing all the 2 VMs, basically. We have 600 some nodes sending data to it. We are very happy.
Yeah, we have 2 boxes, at least for, well, they're kind of generic. We just call them AI metrics boxes, but I mean, we're open to anything. Prometheus was kind of, again, what Nvidia had. They kind of packaged it, right, in the DevOps setup and some of their utilities, that it was kind of something that they went for. And again, since they were building the DGM exporters for Prometheus, it seemed kind of a logical progression. But we also run influx for the rest of our cluster for standard node information. So yeah, we're open to investigation for sure.
Yeah, the nice thing about the Victoria metrics is it's wire compatible with Prometheus.
Okay.
So all the exporters are all the same between them.
Okay.
And even in most cases, it's feature compatible. So they implement any new feature that comes in Prometheus in the Victoria metrics.
Well, thank you.
Any other questions for Eric?
See a couple of things in chat here. I'll make note of those. And yeah, Nick, I guess you asked about setting up Prometheus. Yeah, you can feel free to email me if you want. I'm open to that.
So Eric, what kind of job sizes do you usually see for these GPU jobs in terms of how many GPUs are consumed?
That's a great metric to collect. Yeah, I guess that's really the problem. I honestly don't know. I mean, it would be a guess because I don't have anything, and I guess that's kind of what users or what management is looking for, is that same type of information. Is what is the average request size? It probably could be pulled from Slurm today. I don't have that in front of me, but would be useful to know. I think it depends. I mean, we're still doing a lot. I mean, our AI team here is still doing a lot of kind of the Gatortron project, where they actually, I think they have half the cluster almost for a lot of their work at any given time. So, and they use every GPU. So, you know, they're purpose built, you know, that software that they're working with is intended to utilize an entire cluster. I think they're an edge case. I don't think we have many other kind of general researchers that are doing stuff like that. But I wouldn't even say that most of the requests, at least I've seen when I look, is going to be really over 8. You know, I don't think many people are looking for more than a whole node. I think part of that may be related to maybe how do I do MPI across GPU nodes? I mean, I don't know how to do it, but I'm sure people do. It's just I'm not sure how prevalent it is right now, at least with our current workloads.
This project, you know, you've been working a lot with Nvidia. What has that support been like throughout this whole project?
It's actually been pretty good. We've had to rely on them a lot. It's been a good relationship. We've got a lot of communication back and forth between us now. I think we're even, you know, in some regards, maybe driving some of their product development by our feedback, you know, on how some of this stuff is set up, what the systems look like. Even from a hardware perspective, you know, we're constantly doing things that are pushing limits, and we're asking them, you know, with HPL, I wasn't super integrated in kind of setting this up. That was Craig Prescott that works with me. He was definitely an integral part of that project. But, you know, it's constantly kind of back and forth with NVIDIA. Says, hey, I tweaked these settings, I made these changes. Let's run HPL again. How, you know, what do we get now? And then they're like, oh, well, what if we make these changes? And there's definitely a good collaboration there, and still is. I mean, we work with at least one of the guys weekly. At least I do on this metric side, trying to figure out, you know, what do we set up? You know, what do our dashboards look like? What does upper management want? So we've kind of got a direct contact there. We still have a handful of people that are working with us kind of on the Gatortron project. I think we're entering a new phase of that, but you know, NVIDIA, there's a couple of their staff that's involved there. As far as hardware support, I know I didn't really talk much about hardware. Hopefully no one's on here from NVIDIA, but we've had a lot of hardware issues. But they've been very good working with us on that realm too. We've got like a Slack channel that's opened up. We have a Slack Connect set up, where we have a couple of their guys. And again, we've got a couple point men assigned to us, really just to handle our support cases, to handle hardware issues. And they've done they, you know, took some time, but after a while, you know, they really jumped on board and they got in front of it, and they're actively working with us pretty much the whole way through, you know, determining what the problems are, making sure that, you know, new parts are shipped, making sure that, you know, techs are on site. So it's been really good in that regard. I mean, there's a lot going on, but yeah, I mean, I think just keeping communication open has helped. And like I said, really, we kind of relied on Slack for the majority of it, just to be able to ping each other. Like, you know, we actually kind of proposed that to them, to say we need a better way to reach you. They were, you know, agreed to set something up with us there. That has helped get us through to where we are now. I think we're stabilizing, I think, at this point. So yeah, now it's just a matter of getting some data out of it and letting researchers run with it.
Great. We had a question in the chat from Michael Robert. Is there a public link for the NVIDIA optimized version of HPL?
That's a good question. I could find out.
So maybe while we've got a second, let me throw out a slightly different question, kind of related to the picture you've got on the screen, actually.
Okay.
You know, from the picture, it looks like you have 5 DGX units in a rack. What has been kind of the thermal power cooling kind of aspects of hosting these things? Is 5 really what's in the rack? What was the motivations, et cetera, et cetera?
Yeah, there is 5 per rack. So actually what's interesting is we are all air cooled. Our data center manager, he knows what he's doing. He knows how to set these things up from a cooling perspective and to set up the air conditioning and air handlers in the data center to actually properly air cool these things. He's been phenomenal as far as regulating that. Now, when we were running HPL, we tried a little bit of everything to get them as cold as possible. He was able to crank us up to where I think we were getting like ambient temperatures of like single-digit Celsius temperatures. Like, it was cold in there. It was freezing cold. You had to wear a jacket to get in there. And that was mostly just for burning, for benchmarking. But yeah, so there is 5 per rack. And if I go back up to, this is a whole row. So what do we have? Yeah, so we have set, what is it? 4 rows worth, is that right? One of the rows is a little shorter, but yes, this is an entire row. So there's 40 in here. But yeah, so you can kind of see in this picture, you can see our the vent tiles there have a direct airflow to the front of the rack. We experimented a little bit with kind of some hot aisle containment, which that actually proved to not really help much at all. But there are, you can kind of see at the end, there's a shorter rack at the end of the aisle. That is, it's like just a big fan that will blow the air out around so that it limit like kind of the wraparound warm air. So I think one blows one way, one blows the other way. I don't remember the details of how those work. But yeah, it hasn't been a huge challenge. Like I said, the equipment that got put in, the air conditioning units and stuff, have held up really well. We've since turned them back kind of down a little bit. They're not as cool as they were. But yeah, we haven't really had any thermal issues. We did have a couple, some of the Mellanox cards, the HCAs actually were reporting some thermal things, and they tended to maybe be in the middle of some of these. But I think even some firmware has helped with some of that. But back to the support thing too, even firmware updates, we're constantly getting them from Nvidia. If we find a bug or a glitch or something, we let them know, and they're turnaround's been pretty good on those kind of things too. Like I said, I think we're kind of driving some of this, maybe as one of the larger deployments, right? We're finding issues first.
All right, well, we're a little bit past the hour, and so we'll go ahead and wrap this up. So thank you, Eric, again for presenting your work.
Yeah, no problem. Thanks again for having me. Hopefully that was informative or help get somebody thinking. But yeah, feel free to reach out to me, via email if you want. Open to discussion really anytime.
Right. So before we end, I'll just talk a little bit about next month's talk. Tentatively planned, we'll have a site-to-site network troubleshooting techniques and approaches being presented by Eli Dart of ESNet. So that will be held on October 21st. So get that day in your calendar. Other than that, we do have an opening for a committee position on the Systems Spacing Track Committee. So if you're interested in that position, please either let Brian or Betsy Hillary know, and they will walk you through anything that you may have as far as questions with that position. And with that, we'll go ahead and call it. So thank you all for coming, and we'll see you next month.
Thank you.